Sir, voice is clear.
Yes,
Hello.
yes. Yes, yes.
Hello, everyone. My name is Ashwin G. Kumar. I am an AI student from Sri Shankaracharya Computer Center in Pakistan. I have completed MA English and currently I am pursuing Master Certificate Program in Artificial Intelligence. Today, I am going to discuss about machine learning and its clustering model case study and other basic things. This is my clustering model topic, employee attrition and factors clustering. Here, the attrition means employees turnover. Then, screen is visible.
Yes, yes.
Okay. Here, this is the introduction. Employee attrition refers to the gradual reduction of a company's workforce due to resignations, retirements, layoffs, or other reasons where employees leave and are not replaced immediately. It is often categorized into two. That is, first one is voluntary attrition, second one is involuntary attrition. And these are the impacts on businesses using the employee attrition. Here, we understanding and managing attrition effectively is crucial to minimizing these impacts and maintaining a stable and productive workforce. This project focuses on clustering employees based on factors contributing to attrition such as demographic information, job-related attributes, compensation, work environment, and performance indicators. By grouping employees with similar characteristics, the study aims to uncover patterns and insights that can guide targeted interventions to reduce attrition rates. Here, this approach leverages machine learning techniques, especially specifically clustering algorithms to analyze the dataset and derive actionable insights. These are the advantages of clustering for attrition analysis. The clustering in attrition analysis offers several advantages, providing valuable insight into employee behavior and helping organizations develop effective retention strategies. Here are some key benefits. The first one, identifying attrition patterns. Second one, segmenting employees. Third one, proactive retention strategies. Fourth one, data-driven decision making. By leveraging clustering techniques, organizations can gain a deeper understanding of employee dynamics, implement targeted interventions, and improve retention outcomes effectively. And the next one, these are the disadvantages of clustering for attrition analysis. While clustering offers valuable insights for attrition analysis, it also has certain disadvantages and limitations that organizations should be aware of. This includes, for the first one, subjectivity in feature selection. The second one, complexity in determining optimal clusters. Third one, overgeneralization. By being mindful of these limitations, the organizations can take steps to mitigate the risks associated with clustering and ensure its effective application. In attrition analysis, combining clustering with other methods such as predictive modeling and qualitative insights can provide a more holistic understanding of employee attrition. And next, what is clustering in machine learning? Clustering is a type of unsupervised machine learning techniques that organizes similar data points into groups or clusters based on their characteristics without relying on predefined labels or categories. Unlike supervised learning, clustering focuses on identifying patterns and relationships within the data autonomously. The goal is to group data points such that those within the same cluster are more similar to each other than to those in other clusters. These are the challenges and purposes in clustering. Here, the next thing we discuss what is key clustering algorithms. These are the these are some key clustering algorithms. First one k-mean clustering, second one hierarchical clustering, third one Debian scan or density based spatial clustering, and fourth one Gaussian mixture model, that is GMO. Here we briefly discuss what is k-mean clustering. The K-mean clustering is a unsupervised machine learning algorithms that groups data into triple K clusters based on their similarity. It works by assigning each data points to the nearest cluster centroids and updating the centroids iteratively until they stabilize. It's simple, efficient, and widely used for tasks like customer segmentation, image compression, and pattern recognition. These are the steps how k-mean clustering works. First one, initialization. Second one, assigning points to clusters. Third one, updating centroids. And fourth one, repeats. And next, we discuss what is hierarchical clustering. The hierarchical clustering is an unsupervised machine learning algorithms that groups data into clusters by creating a hierarchy. It builds a tree-like structure, that is dendrogram, to show how clusters are formed. These are two types. First one is agglomerative and second one is DVC. These are the steps how array clustering works. First one, two approaches. Second one, distance matrix. Third one, linkage to criteria. And next, we discuss about what is the evaluation matrices used in clustering algorithms. First one, Silat score. Second one, Kalinski-Harbach score. Third one, elbow method. Fourth one, Davis Baldwin index. And fifth one, adjusted rand index, that is ARI. Here, the ongoing employee attrition and factors clustering project, clustering could help us discover patterns in employee data that influence attrition, such as work environment, performance, or demographic factors. Let's conclusion. The clustering has helped identify distinct patterns and factors contributed to employee attrition, such as job satisfaction, performance, and tenures. Here, this clustering allows business to spot trends and take a proactive approach in managing attrition, reducing turnover rates, and improving employee satisfaction. This is my GitHub link. Okay, and next. We discuss about a case study. This is my clustering model topic, employee attrition factors clustering. The introduction and its other things we already discussed. These are the datasets include columns like first one, age, attrition, business travel, daily rate, department, distance from home, education field, employee count, employee number, and etc. First of all, we import the library using pandas, numpy, matplotlib, seaborn, and import standard scaler, label encoder, k-mean clustering, and other things. Next, we load the dataset using this pd.read underscore CSV function. This is dataset URL. And then we print the first 5 rows of this dataset using this header function. And then we check the information of this dataset using this info function. Here, using this drop function to drop the unwanted columns like employee count and over 80. Here, we check the any missing values exist. Here, there is no missing value exist. Here, there is no missing value exist, but finding missing values using these functions, using these value count and unique functions to find any non-values exist. Here we use the iteration column, business travel, department, education field, gender, job role, mental status, and etc. to find any non-values exist using these value counts and unique functions. And then we print the column names using this column function. Here we import the label encoder, and then we initialize the label encoder using this code, and we apply the label encoder to the column names, attrition, business travel, department, etc. Here we using this label encoder function to transform the objects into integers. Here first one, here the business travel is object, and then we using this label encoder to convert the all objectives into integers, and then we import the standard scalar. These are the numeric columns of this dataset. Here we use the standard scalar to update the data frame using these codes and fit and transform the data. Next step, that is EDA, exploit data analysis. Here we create a box plot using these codes. Here the X value is attrition and Y value is monthly income. This block box plot shows the distribution of monthly income for employees grouped by their attrition status. Example, yes or those who left, and no for those who stayed. Here the yes is 1 and no is 0. It helps to compare the median spread and presence of outliers between these two groups, revealing potential relationship between income and employee attrition, that is turnover. And next we create a histogram plot using these numeric columns. Here the purpose is to visualize the distribution of numeric features in the data set. Here the peak in the histogram indicate the frequency of specific ranges of values, and the skewness left or right reveals the data distribution, example normal, skewed, or etc. And the gaps or multiple peaks might indicate outliers or the presence of subgroups in the dataset. And next we create a box plot using these functions codes using the numeric columns. The purpose is to summarize the distribution of central tendency and variability of numeric features and identify outliers. Here the components are: first one box represents the IQR showing the middle 50% of data. The line within the box represents the median. The whiskers indicates the range of the data excluding outliers, and the points outside the whiskers represents outliers. And next we create a feature correlation heat map using these numeric columns. The purpose is to visualize the pairwise correlation coefficient between numeric features in this dataset. Here the color coding, the color gradient example blue or blue to red in a cool warm scheme indicates the strength and directions of the correlations, and the positive values, that is closer to +1. Strong means strong positive correlations, and the negative values, that is closer to -1, means the strong negative correlations. Fourth one, the value near, that is 0 or 0 weak or no correlations. Here the numeric values in each cell shows the exact correlation coefficients. And then we remove the outliers using these remotely functions. Here df underscore filters equal to df.copy function. Here we create a copy to avoid modifying the original data frames, and then we using the IQR method. This is the 25th percentile, this is 75th, and this is IQR interquarter range. And we apply the IQR filter. And at last, we clean the data frame using this df underscore clean function code. And next step, that is clustering algorithms. Firstly, we use k-mean clustering. Here, using these codes to display the visualization of k-mean. The visualization shows the results of applying the k-mean clustering algorithms to the dataset. The data points are plotted with age on the x-axis, and monthly income on the y-axis. The color coded based on their assigned clusters, that is 3 clusters in this case. Here, 3 clusters. K-mean groups the data into clusters by minimizing intra-cluster variance. The different colors represent different color clusters identified by the algorithms. Next, it is hierarchical clustering. Here we import the agglomerative clustering, and then here also we using these codes to display the visualization. Here, x-axis age and y-axis is monthly income. This code applies agglomerative clustering to group data into 3 clusters and assigns the cluster labels to a new columns hierarchy clustering in the data frame df. And next one, that is GM, Gaussian-Mixture model clustering. Here we first of all we import the Gaussian mixture and then we visualize the Gaussian mixture plot. Here also the x-axis age and y-axis monthly income. This code applies the Gaussian mixture model to group the data into 3 clusters and assigns the cluster label to a new column, that is GMM equal to cluster, GMM underscore cluster. This is a new column in the data frame df. Data frame df. It then visualizes the clusters with a scatter plot where x-axis is age and y-axis is monthly income, using a different colors using these variants thing. And next, the evaluation matrices. Firstly, we use Silhouette score. The Silhouette score measures how similar an object is to its cluster compared to other clusters. Higher value indicates better defined clusters. Here, here we have seen the Silhouette score of all 3 clusters came in hierarchical and GMM using these codes. These are the Silhouette score of k-mean, hierarchical, and GMM. Next, that is Kalinske-Harbach score. The Kalinske-Harbach score index, also known as the variance ratio criterion. This measures the ratio between clusters dispersion to within cluster dispersion. Higher values indicates better clustering. Here also we have seen the Kalinske-Harbach score of all 3 clusters using these codes. Cluster algorithms using this. This is the cluster algorithms, k-mean, hierarchical, and GMM. This is the scores. And then we compile all results together using these codes. This is a prediction of which cluster model is best. Based on the Silhouette score and Kalinske-Harbach index, the k-mean algorithm is the best performing clustering model for this data set because this is the highest one. It provides the most well-defined clusters with higher inter-cluster separation and lower intra-cluster dispersion. This is highest among 3s. This is highest. This is second highest. This is the lowest. This is the visualization of the results based on the Silhouette score comparison, and this is Kalinske-Harbach score index comparison. And last, we save the model. Final thoughts. The clustering employees based on attrition factors is a powerful tool for improving organizational health. It not only aids in understanding the workforce better but also supports creating a positive work environment, enhancing employee satisfaction and driving long-term success. The employee attrition factors clustering case study reveals key patterns behind employee turnover by grouping employees with similar characteristics. This enables organizations to identify at-risk groups, address critical factors like job satisfaction and workflow load, and implement targeted retention strategies. By leveraging data-driven insights, companies can proactively reduce attrition, enhance employee satisfaction, and foster a more stable and productive workforce. At last, I believe everyone will understand it at least a little. If you want to know more about this, here, this is my GitHub link. It also has other clustering model case studies and its YouTube explanation videos. Thank you.